I'm really, really happy to be here. Last time I was here with my students. I teach in London, and it was amazing. We went through Rajasthan. We went to also Auroville in the south. It inspired one of the projects, maybe one of our milestone projects. This is Galaxia. It's in Burning Man. I don't know, has anyone here been to Burning Man? It's a place in the US, a temporary city in which people can experiment and then leave no trace, completely unbuild the city after it's done. So I'm going to take you there. There is many places I'm going to take you. I have, I think, 45 minutes with you, so I hope I'll take you on that journey with me. So this is the temple. It's a temple without any religion associated with it. It's a fully secular and inclusive temple. And something that I find very interesting with Burning Man is that it's hard to build there. It's a completely remote place. And the founder of Burning Man actually said that it's because when you struggle together, you actually create a sense of community. And there's something really nice about involving people. We built this with about 140 people in a kind of short time, 18 days. And so it actually kind of united people around something common to build. And this has continued throughout, whether it's with my company or with this project. This was done last summer. We actually think of the people, and I think it was really nice to see the presentation before, the idea of the people first. The idea that the people with whom you're building matter as much as the piece itself. In a way, you start with a journey, and that journey involves so many people with you that you have to think of how this can be built by people that are not necessarily very familiar with projects. So all our projects are, I call them volunteer-friendly, meaning that they can involve people in the making and in the unmaking of them. So this project was built, and then it was unbuilt. And I'll show you where it is and what's the plan with it. It's always interesting to think of projects as an opportunity to think long-term, invent something. You know, as architects or designer, we're tempted to just make a creation and then that's a one-off. We don't really think always long-term, and I think we have no choice anymore to think in that way. So a lot of our projects are actually made in our little factory. We called it FabPub for Fabrication Public. So it's our two companies. Mamou-Mani is my architectural studio where I can go a bit crazy, but FabPub is actually a shared company that is open to the public. And what that means is that everyone has access to the thing itself, not necessarily just drawing a representation of things, which is often what architects and designers do, and then send it to contractors or factory, but actually make the thing and therefore be confronted with the thing. So therefore no escaping the understanding of the materials, the hardware, the software around the making of things. And I think that boundary between designer and maker happened somewhere and paralyzed us a little bit. The idea that you can have the direct output of what you're designing means that that boundaries doesn't have to exist anymore. And that means we can design better and then also build things that are a bit more truthful. So I'll show you a few examples of how this is being applied. This is in Mexico. It's a hotel, but it's also made from flat pieces of timber. And so this is a sawmill in Bacalar in Mexico, where we actually studied the curvature of timber and bend them into these geometries. So the idea is to use, as much as we can, reclaim timber and actually use the computer to curve them into position. So rather than impose a curvature onto our material, we start from the material and then bend them into position. This is what happened on this project. It's actually talking about custom software that are circular. I'll speak a lot about circularity. This is actually starting from straightness and curving around, which is a bit kind of a strange concept for people that do parametric design, because we're so used to drawing a curve and then cutting it out, rather than kind of think where curvature can naturally emerge from what comes off the shelf. You know, there's a lot of products that come off the shelf and that we think are from the past. They're not necessarily relevant for us, but actually it's this understanding of placing off-the-shelf material within our computer that probably will help connect ancient craft or traditional methods with our contemporary approach. This is a sheet of plywood. It's a very thin sheet of plywood that is laser cut. And the cuts allow us to bend it like a big origami, a high density origami, which forms double curvature and little panels that are based on the size of a plywood sheet. And therefore, we create these sort of extraordinary spaces. This is the boardroom of Orange Telecommunication in Paris, from a custom element made from an off-the-shelf piece of material. And in that sense, it's maximizing inexpensive materials. It's using a very thin amount of material for something that's extremely three-dimensional. So although I'll speak about 3D printing and so on, sometimes it's not always the solution. Digital fabrication enabled to do things that are a bit more holistic than just 3D printing. This is a giant sort of smile. We call it a smile. It's at the entrance of Orange HQ. And it basically opens up slowly and forms this curvature from sheet materials. And these panels are actually forming a three-dimensional geometry that would otherwise not be possible without these folds. You know, at school, I was always told, like, you can't scale these origami projects. You know, you cannot. It's paper. But this is 0.8 millimeter thick. It's made from Zintec. And basically what it allows us to do is to go extremely thin, flat pack, and deliver these modules to create this sort of non-custom project based on standard sheets. This is the Tower of Buma. I was told that in Sanskrit it means the earth. And it's in Indonesia, Bali. And this is a bridge, an old colonial bridge that the client bought, and it was unused. And the beauty of timber, especially this is called ironwood. It's a very, very dense tropical timber that you really cannot cut anymore. When you think of timber, it sounds like it's the solution for everything, but some trees take so long to grow that it's just unsustainable. And we have tons of these unused but precious timber. And so we dismantled the entire bridge and put it through the sawmill and build a tower that you see here. Now, when we think three-dimensionality, we always are tempted to make everything three-dimensional. Even the center tower was, and at the very beginning. And I think quickly realized that you don't need three-dimensionality everywhere. And the skin is made of rattan, which is a much more sustainable material when it comes to cutting it and using it. And it was meant to be bamboo, but bamboo somehow couldn't be exposed to the harsh condition unless we treated it with some kind of weird epoxy and so on. So a lot learned around this project about the real aspects of sustainability in a way. I think there's a lot to be learned when we speak with people, when we understand the products that are being used. And so that project was extremely beneficial in that sense. FabPub is our, our factory, our fabrication, our hub to empower others to use fabrication methods. And here we have what's called a augmented reality technique to take materials that are also off the shelf, i.e. metal rods, rebars used for concrete. And we have a model in the computer that we then send to the Microsoft HoloLens, which are these glasses. And this tells us where to bend, and then we use standard pipe bending tools to bend them in position. Now, this means that anyone, like from my students to anyone who was interested, could come and build this. This was a project we did for the World Cup lately. It's still there, but this complex geometry, we had about 2 months to build it. And I'm sure you get these crazy deadlines too. And so knowing that you can use technology to build really, really unusual geometries using technology is I find this really inspiring. That technology can empower people and help us build better things, more sustainable things is what really inspires me. We did a software. It was really nice to hear all the custom software that we saw. It's called Silkworm. What it does is that it takes a geometry and transforms it into these lines of code, which is what the 3D printers, the CNC machines can read. Basically, it's called G-code for general code. And they're just simple line of go there, extrude that much, go there, extrude that much. But the more we can talk to the machines directly, the more we can do craft with the machines, the more we can not be controlled by them in a way, but to make it a collaboration. I think there's a lot of fear that robots will replace us or the craftsmen. I'm always being told, you know, oh, how dare you deal with that? You know, our craft is ancestral, but I think that dialogue needs to happen simply because it's extremely empowering. And what it does is that it brings back fabrication to local places. So this is one of our printers. We have quite a few of these 3 meters high 3D printers, and we use biomaterials, namely fermented sugar, also known as PLA, polylactic acid, to form these furniture, pieces of furniture. Basically, what you're seeing is a stool printed in a couple hours, locally, in our spaces, on demand, parametric, which means that not only we can print, but we can also crush and reprint. And that means we can offer to people the ability to be part of this way of life. And for me, that's really important because we're so used to buying furniture, buying designs, and then we're kind of done with it. We're not told what to do long-term with them. I mean, sure, they can have a value. You can resell them, recycle, but where to recycle? Where to compost if it's compostable? Where to... So we decided to cover the entire life cycle and have the ability to create geometries and product that are fully circular. So we do bioplastic, but also ceramics. Ceramics can be 3D printed. And this is really a kind of interesting mix between ancestral and contemporary technique. And what it does is that enables the sort of strength of 3D printing to create really thin elements, really minimizing materials, whilst using a material that's everywhere. I mean, clay is everywhere and very often locally extracted. There's no big mine of clay, I think. It's really something that is found in many, many locations, whereas it's in its terra cruda mode or terracotta. And so you can mix it with these you know, geometries that are really, would be otherwise very hard to make with ceramics. And it can be done on site. So this is a store we have in Paris now. And basically what we're doing is we have the printer and we are actually kind of selling on the spot. And that's quite, for me, revolutionary because I'm so used to go to a store and then you buy something and it's like, you know, made in a place that's really far, it had to be shipped. And the ability to have the production method just next to the store is something that I find, yeah, it's gonna change things. And it can work at many scales. This was a crazy project we did with Arup, a skyscraper scale, where these were equivalent to shipping container, let's call it this way, but timber versions. And we were gonna use a robot cable that we actually managed to do in our lab at the time. It was quite an experiment, but with 8 winches and kind of like a spider cam, we had the ability to control very precisely this crane, which is not so dissimilar from you know, a crane mixed with a spider cam. And the idea was that we could assemble and disassemble the tower. So to think of the afterlife of that tower, not just, you know, build a big skyscraper that stays empty, which happens a lot, unfortunately. It's kind of weird to think that we build things for disassembly because architects are so used to making timeless pieces and you know, but maybe there's timelessness in the module, in the thing that you're, in the systems. And so we have the printer in which we put all kinds of materials in the funnel, and then once the pieces are done, we crush them. And then it gives us this, this powder that we can reuse. It's about, so PLA is about 80% less carbon than petroleum-based plastic. It's edible by, you know, enzymes, which means that it doesn't end up as microplastic in your body. We did what's called a life cycle assessment to compare polylactic acid from ABS, which is petroleum plastic. And we noticed that it was pretty much better on every aspect, apart from maybe land use. And that's a challenge that I find really interesting, which is infrastructure. How can we grow material rather than mine material? How can we think of, what sort of sugars, of starch, can generate the plastic that we'll have tomorrow? I mean, it's a big question, because if we were to just use corn, we'd have to use 50% of all corn production in the world. And obviously, it's not possible. So can we do vertical farms? Can we think of other, vegetables or, algae that generate enough starch for it? And that infrastructural thinking is really what activates us all the time. Research, constant research on, can we actually have vertical farms next to our printer, next to our composter, next to our recycler, and have the entire cycle to offer people that way of life, and for them to actually have access to it, because we struggle to even find a composter in London. So we did an exhibition for the Waste Stage. This was at the Design Museum in London, and it was made from the PLA and from scaffold poles and so on. I really enjoyed the MVR RDV kind of relationship between off-the-shelf material and more custom. And the good thing is we could do a live analysis of the CO2 that was generated by the piece and compare it with other material. I think the software of tomorrow not only will allow you to design through geometry, but it will also tell you exactly the carbon weight of everything you're doing. And so that's really kind of key, because we never united the financial cost with the environmental cost. We just buy what's cheap, Like, we just go and we have a plastic bag, we just use it because it's convenient, but we don't think that this will have a lifespan of 1,000 years, just because we are not really conscious of environmental cost. And so that is a big question that is really hard to ignore now that, I know that we're responsible architects for, I don't know, something crazy like 30% of all carbon emissions. So I can't, it's too much on my conscience to make decisions like this now. So there's the material and there's the geometry. Like, when you see an egg, for example, is extremely thin, or the Eiffel Tower, actually, that if the Eiffel Tower was like a meter, it would weigh a couple grams. And so I love thinking this way, how much would it need of material? Everyone thinks this is made of glass, but it's made of sugar. It's for Fortnum and Mason, the shop in Piccadilly. And basically, the curvature enabled us to go extremely thin. The nozzles are about 0.7 millimeter. And so it's so lightweight, which is amazing, because ceilings just cannot take the weight of very huge chandelier and so on. And it goes with, cultural artifact. It doesn't have to necessarily just be these geometries. I set myself a challenge to build my home with environmental materials. And that's a massive challenge. Trust me, it's so easy to go for plasterboard, to go for toxic paints, to go for, petroleum-based plastic everywhere. It's everywhere. Even bamboo flooring is mixed with epoxy. And actually, when doing it on my own home, I realized the challenge that we were facing. So 3D printing has enabled us to do quite a few things, including something I'll speak about, also very personal. I got a sapphire when I last came here, and I knew I wanted to propose to my wife. And so I created these different iterations of our ring, of our engagement ring. And this was actually printed in wax and then sand-casted into white gold. And you'll see, I'll speak a bit about my wedding then that follows, because it's an interesting journey, but I had to put it there because the approach can work at all scale. This is another chandelier, also culturally influenced. So technology is not always remote, or how can I say, it doesn't have to be an identity-less piece. On the contrary, it's because we don't have molds, because you can do any geometry to some extent, that you can bring culture. And so this was inspired by the stone traceries in cathedrals. And we built this in Edinburgh. And it is now being built, and I look forward to actually showing you how it looks. And on a facade scale, we've been exploring a modular approach to facades as well. And so when it comes to 3D printing, it's really slow. And so you see these lines. I don't know if the resolution enables to see them, but this is printed extremely fast. And it's really important if we're going to start thinking a bit big. This is going to be built in Manchester, and the entire skin will take, gazillions of modules. And so when we think in terms of size, when we think in terms of sending shipping containers with the printers inside, we're going to have to think a bit differently, light, and with structure in mind, with holistic thinking. This was probably the largest PLA installation built to date. It was in Milan Design Week, and it's made of 500 of these bricks. But really, they're extremely light bricks. They're even hard to see. And the density of that project was foam, just like foam. And really, the idea was just to take our printer, take the largest module we could print in our printer, and orient these diagonals so that we maximize tension rather than compression. So by doing so, you can actually make all your material act like cables and therefore need a very, very little amount of material. And so in that sense, whether it's completely in tension or completely in compression, if you can kind of visualize the forces in your structures, then you can use exactly the right amount of material. And so this was in Saudi Arabia. Obviously they didn't have the sugar there, and so we did this with Chris Precht, a wonderful architect, and really because it's sand, it's really not good in tension at all. And so you can see here, we used local sand, that was the idea, to 3D print a sort of urban bench infrastructure. And we actually kind of limited it to the property of the sand we could find and the resin that was mixed up with it. Early versions looked like this, then quickly realized that we couldn't build these out of the, I don't know, I thought maybe the dates on the palm trees could have nice sugar. But obviously we don't have our factories just yet to transform it. One day we will, maybe. So we used the sand, mixed it with a resin that would layer by layer bring to life these bone-like structures, which really used as little material as we could, given the kind of current constraints. Another desert, and I promised to take you there. This was the desert of Burning Man. So in Nevada, there's a desert called Black Rock, and there's this, I want to say, positively crazy person who thought we're going to build a city of 70,000 people, and then we're going to unbuild it completely. And it's going to be based on 10 principles: radical inclusion, gifting, no money, just pure gifts, decommodification, self-reliance, everyone is responsible for themselves, immediacy, leaving no trace. Quite pioneering concepts, I must say. And the other idea was that everyone would be the artist. It wouldn't be a festival where you consume, let's say, cultural products, but a place where you're all are the artist and the participant of that festival. And so instead of doing art about a state of society, we do art that creates society around it. I really love that concept, and so we decided to bring our students from university and build structures with them. And so we thought again about the materials, the off-the-shelf materials, and how to maximize them, and therefore how to make them volunteer-friendly. So the things you're seeing here are made from 2x4-inch timber, the timbers that you can find out there. Our tents, because we also had to think of our living quarters, were made of like foam boards that were cut in half to build these yurts. This is like an open source system to build yurts. And then we used the strict, cheapest hand tools, power tools, in order to create this complexity. It's a good challenge when you have to pay for it yourself. And we had to fundraise. And so at that scale, it was kind of okay, but I'll show you when it starts getting challenging. But really learning to fundraise, learning the entrepreneurial aspect of what we do is key to building better, because we're so used to having clients commission us stuff, and we don't feel necessarily there, like where was that money coming from maybe? And we are therefore making decisions that are not necessarily completely empathetic. And so this is when Burning Man was actually very, very helpful for that. So the project I'm about to show you came from this. This was a crazy request when I just started my firm about 10 years ago. Virgin Galactic, they send people to space, the astronauts, and they needed a hotel before the astronauts go to space. And so I remember when I was a kid learning computer science, we had this thing called Logo, on Mac. And basically what you could do is to send vectors around, a little turtle, and then you would say, turn around the turtle, and then move a couple of feet, and then do it again and again and again. And I remember like spending countless hours just like generating these forms and thinking, wow, like you don't actually need to draw something, it can generate itself. And that's a unique thing, because that's like nature. Nature just grows. Like when you're a gardener, you kind of curate different things that grow. Well, you could think of that approach to design, parametric design, as such a thing. And what's really nice is you can put parameters. We saw it was the city in the project of MVRDV. But as you grow a structure, you can also constrain it so that the light comes in winter and is diffused during summer. And then when you kind of mix this with the ground itself, you know, we had thermal mass, we had labyrinth cooling below it, we used water on the edge, and this created a giant stack effect, which means that we didn't need air conditioning in the desert. And I think this is really kind of, you know, for me, it was a moment of like, aha, this was a project that could unite the parametric design and environmental design, hence the term eco-parametric. It didn't happen, as many projects don't happen, but thinking at the time of Burning Man, where I was taking my students, I thought, well, it's a desert, the land is extremely flat, and there needs to be a very inclusive place that brings people together, a universal symbol. And so this is how Galaxia started. The project is about 60 meters wide, 20 meters high. So to build this, you know, from the UK, we had about 600 applicants to come and build it with us. And we had to fundraise everything. Burning Man gave us about $100,000. We needed $600,000. And so, you know, a few panic attacks later, I'm going to take you a little bit through that journey, because I think it was the kind of epitome of the approach, but also maybe something that we could bring elsewhere. So you'll notice things like ratchet straps holding the project together. And it's interesting because often it was, you know, I had my architect's hat thinking, oh, it needs to be, you know, neat, detailed, and so on. And then just kind of realizing that we had no money to build it. We had people that are volunteers, they're not necessarily builders. It was extremely risky. It had to be built in 18 days, so we had to think of the entire choreography of how to build that, from a scaffold to a sort of bike wheel foundation, because we cannot drill foundation. So everything was sitting on a bike wheel. and the removal of that scaffold and the assembly of modules, all this using off-the-shelf material. So how could we do that? So we did really playing with dimensions, from the one-dimensional pieces of timber to the triangle. Triangles are really hard to get wrong. You know, there's 3 points. It's kind of, you know, if you get the 3 points right, you're fine. And then we assemble this into these unfolded cubes, really, or tetrapeds, or I don't know how you call it. And then we fold them into position. And everything was off the shelf apart from a few custom connections, which had to be done in relation to the forces, right? So depending on how much forces is happening, we had to put X amount of screws. We couldn't afford to have, you know, the worst case scenario applied everywhere, which is what usually engineers do. Worst case scenario, put it everywhere, throw a bunch of money at it, it's all good. No, there was no money, and so they got tired of us. And then they gave us the formula for one screw, the forces themselves, and then just deal with it. What I think was really nice, though, working with them as a real team, was that they maximize tension. So some of these are in compression, some of them are in tension. And then we switch them in the computer until a majority of them are in tension. The difference between compression and tension is huge when it comes to materials like timber, because you can actually, you know, use timber as a tensile material like cables. And so it's pretty amazing to see if you really use what's needed where. So we used 4x4 timbers on the base and 2x4 timbers on the top. And you see that there is a moment of relationship between the two. We ended up also combining 4x4s into 6x4s, 8x4s. The engineer kept on panicking and sending me like, no, actually you need more there. You need. And I was just like, oh, we're running out of timber. Because we had to bring everything to the desert. There wasn't a shop nearby or anything. So I had to plan. Now, we're not being taught project management as architect, Gantt charts, you know, dealing with that sort of stuff. And yet it's so crucial to the success of a project. We often just think of the geometry, of the overall concept. But what about the way to build it? What about the building site? So this was our quote-unquote village. We had all of us living there. We had a kind of canteen here. We had shops in which we could build. And then all of these were the modules unfolded. This was 60 meters, just to give you a sense of the scale. We had like trucks to stage, and a whole bunch of kind of constraints that we don't necessarily think of. And it being a place where no one is a spectator, the temple immediately, when we quote-unquote opened it, continued to be built. People would bring the most amazing, moving things. Like I could hear drill sound and I'm like, oh, enough. Are we still building this thing? And then actually it was people just taking ownership of it and continuing the journey. So they would, actually just keep on adding stuff to this skin, which was really just maybe bones and they were building the skin, And I told my wife, like, it's been so hard together to do this. Like we went through such a tough, let's just take this opportunity to get married. And and we both decided to turn this journey into a really amazing memory. This was our way to use that temple. I mean, the flowers were just the survey flags. My mom here was a megaphone. No one could hear anything. But we had the most amazing memory and experience, turning this into what it became. And then we burnt it. Well, I don't recommend burning anything anyways. It's not the most sustainable thing. Although, saying this, we did an analysis, and the whole project, we wanted to offset it, and it was like the same as one flight for one person, the entire thing, because timber is that good. And we used Douglas fir, which is a coniferous tree that can actually grow in 15 years. So everything we could do, we did. Even recycle all the steel, which actually paid for itself. So the steel was collected, put into the spiles, and then the steel company came back. But they kept on bugging me, and I really didn't want to burn it. So we thought, okay, let's go back and build something that will disassemble and bring elsewhere. And that was Catharsis. And Catharsis was also based on mathematics, an algorithm. This is the Poincaré disk. It's a fractal. It basically circles made of circles, which I thought would be a nice metaphor for Burning Man, that there's no spectator. So what would an amphitheater become within a space that doesn't have spectators? So how about an amphitheater made of amphitheater, made of amphitheater? And so that gives you a sense of the scale. The Catharsis was aligned with the temple. It was the yin to the yang, let's say. And we didn't really finish it. We went through all kinds of struggle. It had nodes, metal nodes, very precise, very well built. People thought, well, what is this? In the middle of the desert, looks like a Swiss chalet, a weird one, psychedelic maybe. But it was really well made to some extent, because we knew we had to disassemble it, which made it, really hard. I really thought, let's just burn this thing. But no, we went through with the idea. It was an amazing journey because, it was not just the project, it was everything around it. This was supposed to be calling people to do things in there, just like the temple. And so, there were amazing artists coming through. There were weddings. I got kicked out of our own wedding in the temple because people said it's a temple. You're supposed to be quiet. And so I thought, let's make a piece where people can actually celebrate without, that pressure of the temple, let's just say. And we had these amazing light artists doing projects. We had an artist called Refik Anadol who did this machine hallucination projection map, which meant that the entire project was just melting away. And honestly, nothing planned, people just kind of showing up and doing stuff. And then we took it down. And our hope was to bring it back to other places. It's still on flatbed trucks. I'm struggling to find ways to do it because I think people are just not used to it. They're just not used to having a piece that was installed in another event being brought somewhere else. I think it's a new idea, as in, maybe not, but I don't know why people are struggling. And there is augmented reality. So you can actually bring the idea of it, at least, if not the physical thing. I mean, I'd love for anyone to want to bring the physical thing somewhere. But if you go, this is, my Instagram, there's this new thing that we managed to code within that, which means that you can actually try it and see it and then share it and see how you can actually experience that, which, is one way to reuse it. So I have about 4 minutes. Just gonna kind of conclude on a few concepts. The beauty of thinking, parametrically, or let's just say in systems, is that you're not thinking of finished things. You're thinking like nature. And what I mean by that is you're letting systems have a life of their own. I think you mentioned that. rather than think of forms that are coming from the top down, the forms are coming from the bottom up. And therefore, you're creating things that can exist in many different forms. This is going to be built in Bucharest. It is obviously inspired by Galaxia, but it's a couple of them because it's based on a hexagonal grid. And this is the same quote-unquote code, just expressed differently. And so, you know, thinking of the merging of nature and architecture, it's kind of paradoxical to think of algorithms or robots as the opposite, and yet they are bringing us closer. And it's not necessarily just coding on parametric software. You can think this way through just a way of thinking, you know. This is sketches that I do once in a while when I pretend I'm a computer. But also through AI, you know, this is something I love doing, which is placing all our projects, all the ideas, and then somehow you see these things coming out. And then it's not immediate. You have to actually discuss with the AI. And so it's just a continuation of that method, which I find extremely exciting. So yeah, let's do this together. And don't hesitate to email me. That's my email. So thank you very much.